All right, good afternoon again. We'll carry on with the program now that we're on time again. So our next speaker this afternoon is on the topic of weather. So what's ahead weather-wise for 2019? And for this presentation, we have Rob Paola, if I pronounce it correctly, who is a retired meteorologist with over 30 years of forecasting experience with Environment Canada's Meteorological Service. He has extensive experience forecasting for the prairies in Ontario with a focus on high-impact weather, as well as climatological expertise. In retirement, Rob maintains a keen interest in meteorology, climatology, and monitoring weather conditions in southern Manitoba with his own website and social media accounts, with a particular focus on extreme temperature and precipitation events. Rob lives in Winnipeg with his wife and daughter. Please welcome Rob.
Okay, thank you very much. Pleasure to be here at Manitoba Ag Days. This is my first time here. I thank the organizers for inviting me today. Hopefully after what I have to say today, they invite me back next year, but don't worry, it's not going to be that bad. So as mentioned in the introduction, I'm a retired meteorologist from Environment Canada. Even though I retired a couple years ago, I still maintain an active interest in keeping up with weather and climate stats for the prairies. And today I'm going to be offering a look at what may be coming up weather-wise for this upcoming growing season. As you can appreciate, it's still early, still 4 to 6 months away, and that's an eternity when it comes to weather forecasting, as we know. But I will try to give you what we know up to this point, all the current information, and hopefully give some indications of what this year might shape up, especially in terms of comparing it to what we had last year. So that's a good place to start. Let's take a look what happened last year as a recap. And you'll see that the beginning of the growing season, the highlight was basically a very cold April. This graph shows periods with above normal or below normal temperatures. The areas in blue are below normal, areas in red are above. We started off the growing season with a very cold April. This is a map for Winnipeg, but pretty well represented much of southern Manitoba last year. The big thing about the spring last year, though, it was very dry. So it came off of a dry winter with below normal snowfall, and that dryness continued into the spring. So even though it was cold, it remained dry. So you still had quite a bit of frost in the ground in April with very little precipitation. The weather pattern in May flipped. Let's go back one. The weather pattern in May flipped to above normal, and that continued right through the summer with generally with long stretches of hot, dry weather, plenty of 30 degree plus days. And a continued trend with below normal precipitation. So soil moisture levels were still a bit of an issue, and with the heat, it led to some crop stress. By the time we got into the fall, the weather pattern changed again, and it flipped to below normal temperatures again. And this time, the fall started to get a little bit more frequent precipitation events. And that was actually a good thing to replenish some of that soil moisture that was depleted during most of the season. The downside, of course, was the precip delayed late season harvest, especially with some untimely early snowfalls. So that was a bit of a negative, but the benefit was a little bit recharge of the soil moisture before freeze up. This is just a graph to show how the precipitation accumulation occurred throughout the year. This is for both Brandon and Winnipeg. Brandon is in the dark line and Winnipeg is in the blue line. And the precipitation axis is along the right here in inches and millimeters. So you can see from December of 2017 all the way through the winter, by the end of February, we still had only picked up about an inch of precipitation in both Brandon and Winnipeg, so pretty dry. And then through much of the spring into mid-May, we had still picked up only about 2 to 2.5 inches of total precipitation in both Brandon and Winnipeg. So still very dry as we entered the growing season. Finally, in late May, early June, we started to pick up some rains that started to punch up the precipitation amounts, and then periodic rainfalls through the summer. But still, by the end of August, we were still only about 10 inches of precip, which was still below normal for the growing season. And then finally, in the fall, we picked up more frequent precipitation right before freeze up. By the end of the year, Brandon had picked up about 14.5 inches of rain or precipitation. Winnipeg, about 15.5. That's about 4 to 5 inches short of what we should have been for the year. This map is from the province of Manitoba Agriculture Department. They operate a network of over 100 agriculture weather stations throughout southern and central Manitoba. So it gives a really nice detailed analysis of precipitation and temperature variations across Manitoba. They operate, their network is a lot more extensive than Environment Canada's network, which is a lot more spread out and not as detailed. So I like using the province's network to give a more detailed snapshot of local variations in precipitation. Anyways, this is for last year's growing season, and it's a map showing percent of normal rainfall. And areas in dark green and blue were closer to normal, about 70 to 90%, mainly through along the Saskatchewan border up to the Swan River region, and also through the northern also through the northern Red River Valley and the White Shell areas, a little bit more precip through the growing season. But for the most part, a lot of southern Manitoba, especially through the inner lake, looking at less than 70% of normal precipitation during the growing season last year, as well as through the southern Red River Valley towards the North Dakota border, precipitation was below normal. This map, again from the from the province soil moisture agriculture network. This is indicating soil moisture levels by the end of October, just before freeze up, for the first 30 centimeters of the soil, the top 30 centimeters. And the areas in yellow are all what they considered adequate. So in general, much of southern Manitoba, soil moisture conditions by the end of October were considered adequate as judged by the soil moisture sensors from the Manitoba Ag Network. That's mainly because we had some of that beneficial moisture that fell in the fall last year. There were still some areas that were below normal. Those are in orange. Some areas are a little bit wetter than normal in green. But for the most part, soil moisture conditions heading into freeze up were regarded as adequate. So we're in reasonable shape, even though it was quite dry last year, where soil moisture levels, as indicated by the Manitoba Ag Network, are in reasonable shape as we head into next year, this year. Taking a wider look across the prairies for last year, precipitation, as Bruce was showing, generally below normal throughout the prairies. In yellow is 60 to 85%. Areas in green were a little bit closer to normal. That's along the Manitoba-Saskatchewan border and also up through central Saskatchewan into central Alberta. For the most part, though, most of the prairies were in the same situation as southern Manitoba, drier than normal during the last year's growing season. So that's how last year shaped up. How's this winter doing so far? And how's that going to impact what soil moisture conditions may be up for the beginning of the growing season? Well, you wouldn't know it from the weather for the past week, but our winter's been generally above normal, milder than normal. These are temperature differences from average across Canada and North America since December 1st. And you can see that the bulk of Canada, the prairies, into much of North America, even the Arctic, have generally been above normal this winter since December 1st. December was mild, and the first half of January was mild. The pattern has somewhat shifted now over the past week. Some colder air coming into the eastern prairies and into Ontario. So that's going to start to cut down the average temperatures for us in Manitoba. But generally, up to now, winter temperatures have been generally above normal. Precipitation-wise, as Bruce alluded to in the talk before mine, precipitation has generally been below normal this winter, as you can see by the yellow and orange on the map, across most of the prairies. A little bit more moisture as we get into central Saskatchewan and central Alberta, and a little bit along southwest Saskatchewan. But a big area of below normal precipitation for southern Manitoba into southern Saskatchewan. So basically, we're looking at a below normal snowpack. We haven't had a lot of snow this winter, so snowpack levels are below what they should be for this time of year. If we go to the Manitoba Ag Network, they measure winter precipitation as well. It's just melted snowfall that melts into their sensors. This is a little bit more detailed analysis of how winter precipitation has been shaping up over southern Manitoba. And you can see, you can see over much of the Red River Valley, southeast Manitoba, it's been very dry with only about 40 to 50% of normal winter precip. This is since November 1st. A little bit more moisture through Westman, up through Riding Mountain areas into the central Interlake and up into the Paw areas, where it's been a little bit more snowfall with about 60 to 80% of normal precip levels up to this time. Still, though, below normal right across the province. So we're looking at below normal snowpack, but it's still only the end of January, and that can really, I mean, we can still get some pretty decent snowfalls in February, especially March. So what's been influencing our weather pattern this winter? Well, Bruce was mentioning this in his talk about the big influence this year has been what is developing El Nino out in the Pacific Ocean. This is that area off the eastern South America along the equator with above normal temperatures in the Pacific that starts to influence our weather pattern here in North America, especially in the winter. Now, this year's El Nino, as Bruce was mentioning, is still kind of in a weak phase and still struggling to get going. But our winter has been behaving like it's in full strength. The other area that has been influencing our weather is this warmer sea surface temperatures up in the Gulf of Alaska and British Columbia. That's also been influencing warmer air over the Pacific. And a lot of that air has been shifting across Western Canada and into the prairies, giving us this milder than normal winter. So this is a schematic that Bruce also showed in his presentation. The top schematic shows what a typical El Nino pattern shapes up. And it's characterized by warmer air off the Pacific coming in across Western Canada and all the way into southern Manitoba and the Great Lakes. Depending on the strength of El Nino, the stronger the El Nino, the more this warm air makes it eastward. If it's a weak El Nino, it tends to just linger more along the west coast and maybe southern Alberta. In a stronger El Nino, Arctic air masses that are north of the polar jet tend to stay up into the north and east of us and don't really get into our area. This contrasts with the opposite current that's in the Pacific Ocean known as La Nina. That would be on the bottom schematic. And in La Nina, the polar jet stream dives right through the Rockies, well down into the US, so we get a lot more colder Arctic air masses coming down and affecting the eastern prairies with longer, more frequent cold outbreaks. That's more typical of a La Nina season. So right now, this year, we've been more in the top pattern, more reminiscent of an El Nino type of pattern. That's what the winter's been like so far. Unfortunately, it does look like things have switched up for the next little while. These are temperature outlooks from the Climate Prediction Center in the U.S. The chart on the left shows temperature conditions expected compared to normal for the rest of January. And you can see there's a lot of blue on that map. That means a lot of cold air over central and eastern North America. You'll notice they don't have data over Canada. They're only obligated to put their forecasts out for the U.S., but you can get an idea of what's happening in neighboring Manitoba and Saskatchewan. But basically, the bottom line is lots of cold air and below normal temperatures expected here for the end of January. And if you look on the other chart here on the right, this is the outlook for the first half of February. Again, a persistence of below normal temperatures through Manitoba, Ontario, and the eastern U.S. Although off on the west coast, it looks like above normal temperatures, as we would expect with a El Nino type pattern. So it does look like the mild weather that we've been having for the first 6 weeks of winter, it's going to be taking a bit of a break here for the next 4 weeks or so. So that takes us to the end of February, basically, or mid-February. What is the spring outlooks from the Climate Prediction Center? I refer to the Climate Prediction Center forecast because they have a group there in NOAA that specifically looks at these medium to long-range forecasts in a lot of detail. They update the forecasts daily, weekly, monthly. They have a team dedicated to looking at these outlooks. So it's a really good site. I'll give you information about where you can access these forecasts, but it's a very good site to look at what the current information is on extended outlooks in the weeks and months ahead. Environment Canada has some long-range outlooks, but they are mainly automated from computer output with very little human intervention in them. So they're basically raw model output. The CPC folks in NOAA have a little bit more human involvement that can take a look at trends, historical comparisons, and make some better forecasts. So what is CPC saying for the upcoming spring? Well, if you look at the maps, not too much for us. The most confident area that we'll see above normal temperatures is along the west coast, again because of that El Nino phase that we've been in. For us, though, there's an area which they call EC. EC means equal chances, which means there's not enough information at this point to say whether it's going to be above, below, or near normal. That's the same with their precipitation outlook. Not enough information at this point to say, because there are no clear signals. The signals so far this year are pretty weak to give any longer-term indication. And if you look at their summer outlook, not much different. So not a lot of information at this point to say what kind of spring or summer we're going to be seeing because the signals so far are so weak. So because of that, is there something else that we can look at to kind of give us an idea of how this summer might shape up, or how this upcoming growing season might shape up? Well, we can do something called analogs, and that's basically look at what pattern we've been having so far this fall and winter and compare it to other years in the past that have had similar patterns and see what happened in those years in the spring and summer to give you maybe a kind of an idea what might happen this year. If we do that, again, we'll look at the Pacific and look at the strength of the El Nino out in the Pacific. And this is a chart showing the different phases of the Pacific Ocean. Either if it goes above the zero line, it's in an El Nino phase, and it's below the zero line, it's cooler waters in La Nina phase. And you can see this is since the pattern since 1950 all the way to 2018. You can see how the cycles change from cool La Niñas to warm El Niños every few years. And depending on how high the peak is, it's a stronger El Nino or a stronger La Nina. So you can see we've had some years with pretty strong El Ninos, and then some years with pretty strong La Ninas. And this shows you the variability every few years, how it goes from one phase to another. About 3 years ago, we had a very strong El Nino, which led to very warm global temperatures. But that reversed to a weak La Nina over the past couple of years. And now this year, we're starting to climb back into a weak El Nino phase. Now this chart shows a graph of the El Nino, of the Pacific Ocean Index. Take a look at the black line there. And this is basically the index since last January up to this year, which is January right now, which is about here. So anything from onto the left of the line is observed index on the Pacific, and anything to the right is what's forecast for the remainder of the year. So you can see that last year we had a weak negative index, which means it was a weak La Nina. But then over the year last year, it started to go positive. And then last fall, it entered what was a phase of the weak El Nino between October and January. It went into a weak El Nino phase. For the forecast for the rest of this year, these are all the forecast models that have various solutions. But if you look at the general trend of them all, this would be along this line here. It suggests that we're going to stay in a weak El Nino through the spring and summer, and weakening as we get towards the end of the year. So right now, the El Nino index is at 0.7. And if we look at similar weak El Nino values in other years, we can see some similar years that had weak values in the fall and winter. Some of these years, 1954, 69, 70, 77, 78, 80, 95, 2005, 2007. Now you'll notice that not every one of those years behaved the same. Some years, like 1977, were quite wet. Some years, like 1980, were quite dry. But if we can combine all these years together and put a composite analysis of all of them together, it might give us an idea of what you may expect this year. So if we do that, we come up with a composite analog map. This averages all those years together and looks at what the general temperature was when you combine all those years. And what we see is basically a pattern where there's warmer than normal temperatures over much of the U.S. Corn Belt into eastern United States, with cooler than normal conditions through western prairies, northern Saskatchewan, northern Manitoba. And the white would mean normal or average temperatures between that cooler air mass to the west and the warmer conditions to the southeast. This is somewhat similar to the positive PNA chart that Bruce was showing in his earlier talk, maybe shift a little bit east, but it does have kind of that similar look to it. Precipitation-wise, if we do that analog, it shows that the red areas, the orange areas, would show generally below normal temperatures over the east, below normal precipitation over eastern U.S., with the blue indicating above normal precip, generally across the northern plains, North Dakota, up towards the Canadian border. So you can imply some wetter than normal conditions over southern Manitoba. Again, that's from the composite analog when you combine all those similar years together. So if you had to draw an upper pattern as to what this pattern would look like for this upcoming year, it could look something like this, where you have the generally cooler, unsettled conditions over Western Canada, Alberta. You have warmer and drier conditions over the U.S. Corn Belt down into eastern North America. And in between these two air masses, you have a jet stream coming through southern Manitoba, and that would imply a little bit more active weather this summer and this growing season than we had last summer. That means a little bit more in the way of showers and thunderstorms, which would lead one to believe that this upcoming growing season should see more precipitation than we had last year. And not as extensive heat and persistent hot spells as we had last year, because you're going to see more variability with this jet stream over us between warm air masses and then being balanced out by some of that cooler air coming in from the west. Now that's very important. If we start to get more in the way of precipitation, that is very important because it starts to add more soil moisture, and soil moisture is very important in the prairies to drive precipitation, because not only do you get moisture in the soil evaporating to give additional moisture into the air, but you also get transpiration from crops and plants to also give moisture into the air. That additional moisture that goes into the air can help fuel more showers and thunderstorms. So the bottom line is you need soil moisture to get a better chance of more showers and thunderstorms to develop. You've heard the expression drought begets drought. Well, that's somewhat true, because if you don't have the soil moisture, you're not going to have the plant growth and the crop growth to release that additional moisture in the air that can fuel more showers and thunderstorms. So the more soil moisture you have, the more likely you're going to maintain additional showers and thunderstorms for the season. So putting it all together, what would the analogs suggest compared to last year? Well, most likely, as Bruce also alluded to, it does look like this year we'll see more precipitation than last year. So more normal to even above normal precipitation levels. So I think it is looking wetter than last year, more precipitation. I think we're going to see a recovery in soil moisture levels over the values that we saw last year, especially how it was so dry in the spring. Because we're going to have more soil moisture, we should be seeing more thunderstorm activity, especially with that jet stream crossing across southeastern Saskatchewan and southern Manitoba, which will help trigger more shower and thunderstorm activity. The downside of more thunderstorm activity is an increased risk of damaging hail or damaging winds for your crops, which is not a good thing, but that's too tough to forecast way out ahead in time. But just to give you an idea that if there's more thunderstorm activities, those hazards also increase. And finally, with a little bit more in the way of showers and thunderstorms and more of the warm, concentrated southeast of us, I don't think we're going to be as hot as last year was, as persistently hot and dry as last year. But we still will have periods of warm, above normal temperatures, but not quite as extensive as last year, so slightly cooler temperatures than we saw last year. So again, just want to caution you that this outlook was based on analogs, which have limited skill, but it hopefully gives you some sense what the upcoming year might bring. Remember, it's a weak El Nino this year. It's a very poor signal. Other factors may influence the type of weather we see over the spring and summer. At this point, this is the best information that we have. Each year is different. Like I mentioned, even in those analog years, some years did not behave like others. This was just an average of all of them when you put them all together. So you have to keep that in mind. The most important thing is to just maintain, keep up to date on the latest forecast and trends as we get into the spring and closer to the growing season. I recommend consulting the Climate Prediction Center for their outlooks. They have very good outlooks that are updated regularly, daily, weekly, monthly, to give you an idea of trends in temperature and precipitation in the weeks and months ahead. Also, the Manitoba Agriculture has an excellent website with a lot of good information on current precipitation amounts, soil moisture, soil temperatures across their extensive network. This is the climate prediction website. There's the URL up there, but you can just Google Climate Prediction Center. And this is their main homepage. They have 6 to 10 day outlooks, 8 to 14 day, 3 to 4 week outlooks, monthly, 3-month outlooks. They have discussion on El Nino, and lots of good graphics to kind of give you a picture of what may happen in the weeks and months ahead. They don't forecast for Canada, but like I said, they go right to the border, and a lot of times you can have a pretty good idea of what they're expecting in our part of the world. And this is the Manitoba Agriculture site. This is their URL, govmb.ca agriculture. If you look on the menu on the left, if you go down to weather and then click weather conditions and reports, it'll come up with all their information on what their network has observed with precipitation, latest conditions and temperatures from their network. They have soil moisture, soil temperature conditions. Every week in the summer, they update it with weekly crop reports to give you a summary of what's happening across the districts. So lots of good information from the Manitoba Ag site that can also tell you what's happening here directly in the province of Manitoba. So that's it for my presentation. If there's any questions, I can certainly take them now. You can also follow me on my Twitter account at @RobsObs. I frequently will post information on updated forecasts, weather conditions, climate stats in southern Manitoba. So you can certainly follow me for that. I also have a website that I have a lot of links that I had here on my presentation that you can access. But that's about it. Whatever the weather, I certainly wish you the best success in the 2019 growing season. Thanks very much. Okay.
Thank you, Rob. We have a good 10 minutes of questions. If you have some, I'm sure you do. Please raise your hand and I'll come up with a mic.
Do you believe in that hoarfrost theory? When you have hoarfrost 6 months down the road, you get rain? Hoarfrost.
Hoarfrost?
Yeah.
And what's the theory?
After 6 months, you get rain.
After 6 months, after hoarfrost, you get rain?
Yep.
No, there's no.
I believe in it. It
no
works.
correlation. Well, the thing is, it's going to happen because hoarfrost usually occurs in the depth of winter on cold mornings with ice fog, and it'll get hoarfrost on the trees. But that's, January to February. 6 months after that, yeah, you're going to get rain. But there's no correlation.
Any further questions? I'm sure there are. Yes, just hang on.
Yeah, I was also going to ask about the hoarfrost, but there's another farmer saying about the full moon. When it happens, it's a change of weather, and I just wanted to hear your opinion on that.
No, those are the moon would have effects on tides, but it doesn't influence the weather. Weather is basically in the bottom layer of the atmosphere, of the troposphere, which extends to about 5 or 10 kilometers up in the atmosphere, and that's where all our weather occurs. The moon doesn't affect that. Like I said, it affects tides, but not weather.
Any further questions? Yes.
On the reserve moisture, we depleted that just as much as you possibly could here in Manitoba. And it hasn't, it's got some in the top 6, maybe 12 inches, but it's just powder down there. And if we wouldn't have had that last year, we would have had a disaster.
Yeah.
And instead we got a good crop. But if we are anywhere, we're going to need above normal precipitation to get a decent crop.
Yeah, no, I totally agree with you. Last year, like you said, we had a reserve from the year before that managed it okay, but if it's dry again this year, like, could be trouble. So like I said, it does look like this year should be more favorable with a more active pattern to give you more precipitation and recharge those soil moisture levels. Hopefully we get a little bit more snowpack too over the next few coming weeks. Yeah, your point is well taken that the reserve really helped the crops last year.
More questions? I have one. I'm just curious, what is the reliability, I guess, of the, when I look at the forecast, I'm thinking after a couple of days I can rely on it for the next 2, but beyond that, what's the chance? I'm thinking it's going down pretty rapidly, or is it just a flip of the coin, or what is it?
Mm-hmm. Well, it depends on what parameter you're asking to verify. Yeah, the most dependable and accurate forecast of the first 2 days, today and tomorrow. Then the probability starts going, the accuracy starts going down after that. For temperatures, basically you're looking at, you should be within 3 degrees on day 3, maybe plus or minus 4 degrees by day 4 or day 5. Precipitation-wise, it gets pretty much a flip a coin by the time you get more than a week in advance. Right now, Environment Canada forecasts, the human meteorologist basically is responsible for the first 2 days of the forecast. After that, it's totally computer automated. The human meteorologist doesn't touch it. So that's why there's kind of less dependability, more variability in forecasts after tomorrow because it's straight from the model and it can flip-flop all the time. So the accuracy just isn't there compared to the first day or 2.
So you're saying the human mind is better than artificial intelligence?
Believe it or not, yes. We can actually make a difference when the human takes a look at the model guidance. They have their knowledge and they can look at what happened, and with their experience, they can massage the model data to make it better. Yeah.
Very good. We still have time for questions. 2:30 is the next presentation, so we can't start much before time. Anybody else? Yes, just hang on.
My question is related to the 2018 disaster for the harvest that we had in Manitoba.
I'm sorry, I didn't get that.
2018 end of the season harvest was a disaster because we could not predict the rains and then the frost that we got. Is there any way this event could have been forecasted by observing what's happening in BC or in other areas?
So I just want to clarify the question that the forecasts in August of last year were very poor.
Yeah, in September we had, like, the weather really changed mid-September.
Yes, yes.
And we started to have rain and then frost, and I think
and snow even.
Yeah, that's
snow.
right. Yeah, that's your question. Yeah. Could it have been forecasted?
Well, I mean, basically what you can do is you can get an idea that over the next couple of weeks we may be trending colder than normal. But to say that 2 weeks from now it's going to snow in Winnipeg on September 27th, 2 weeks in advance, we can't do that. We don't have that expertise. We can look at trends and seeing that it's going to be below normal. And that's basically the best you can do 1 or 2 weeks out in advance. Then as you get closer to the event, then you can start seeing, okay, maybe within 5 days or so, oh, we might be getting some snow later in the week. But to try to forecast abnormal weather, you know, weeks in advance, we just don't have that expertise right now.
My question then would be, does anybody have that expertise?
No, I mean, weather is only predictable to a certain point. You have to realize that the atmosphere is very chaotic, and there's a limit of predictability. No matter how much computer programs you have and how fast your computers are, there's a certain limit of predictability that you can, even if you go out 2 weeks in advance, it's still not going to tell you what's going to happen accurately. The best we can do is give you very good forecasts for the next few days, and then general trends a week or two in advance. And then after that, it's just very basic, cooler, warmer than normal, drier, wetter than normal. But again, it's because the atmosphere only has a certain limit of predictability, because that's the atmosphere.
Any further questions? One more, one last. Yes, hang on.
I just wanted to ask, what's the chances of a drier year again? What's the chances of a drier year again?
What are the chances of a drier year?
Yeah.
Some of those years that I looked at were drier than normal, about 40% of them, whereas a greater percent had near or above average. So there is a chance it could be drier. I'm not saying it can't be. There were more years that were near or wetter than normal, so hopefully we trend that way. But I cannot say for positive that it won't be drier this year.
Very good. I think we'll leave it at that for questions. Let's give Rob a good hand of applause for his time and presentation.
Thank you.